61. A model airplane of mass 0.75 kilograms flies with a speed of 35 meters per second in a horizontal circle at the end of a 60-meter control wire. Compute the tension in the wire, assuming it makes a constant angle of 20 degrees with the horizontal. The forces exerted on the airplane are the pull of the control wire, the gravitational force, and the aerodynamic lift that acts at 20 degrees inward from the vertical as shown in figure P6.621. So they give you this nice diagram, which I copied over into my free body diagram. So we have this great looking airplane here. It's moving at a constant horizontal circle, and there are three distinct forces acting on it. First, the lift. So we just have like the force of the lift, and that's 20 degrees with the vertical. We have mg, which is just the weight of the airplane going straight down. And we have the tension of the control wire here, which I labeled T, and that's 20 degrees below the horizontal. So it's kind of like getting whipped, getting whipped around like a certain apex here, or a certain point here, and then it's just kind of moving in a circle. So the first thing that I did was I defined this as positive inward because it's going in a circle like this, and we always want to do the centripetal acceleration positive. And then positive up because it's the lift. So I just did positives up. So first I just separated all my forces. So it's just sine and cosine. So for the force of the lift, it's force of the lift cosine 20 for this, the y direction. And then force of the lift sine 20 for the x direction going inward. So that's positive. This is positive. mg, you don't have to separate out anything. And for the tension of the wire, we just have positive t cosine of 20. That's how much of the tension is contributing to the centripetal acceleration in the positive direction. And then we have it down. So the tension is pulling this plane down because if you think about it, if it didn't have tension, the plane would just, fly up. So that's negative t sine 20. And then they give you this 60 meters. And the 60 meters is important because we don't really care how long the tension wire is. We only care about the radius of the circle, which we can solve for if we have 60 meters and we know it's a 20-degree angle, which means that it's just, this is just the cosine. So cosine 20 degrees of 60 meters means that the radius of this circle that it's traveling out at is 56.38 meters. And we'll need that for later. Also, they just give you some givens. The mass is 0.75 kilograms, and the speed is 35 meters per second. So the first thing that I did was I just solved out what mg was. So 0.75 kilograms times 9.8 meters per second squared. And so just to have that, so that we can just plug it in easily to our equation. So first, the forces in the y direction. I chose the forces in the y direction first because it equals 0. Because it's not, moving up or down. That's what it told you in the problem. So the force of the lift, cosine of 20, which is up, minus, which is this tension down, tension sine 20 minus mg equals 0. And I just solved for mg, which is 7.35 newtons, which I got from this equation, if you were wondering. And then now we don't know force of the lift or tension, but we do have another equation, which is nice. And so we're going to have to do systems of equations. So now forces in the x direction. We have this top force, which is coming from the lift. So force of the lift sine 20, positive direction, plus this force, tension cosine 20 in the positive direction, which is, from the tension, equals mass times centripetal acceleration, which we can also solve out to v squared over r by the formula. And I just did a little, the math here. I didn't want to write another line. So v squared is already given, 35 meters per second squared. And we solved out the r here, which is 56.38 meters, times the mass, which is given. So 0.75 kilograms equals 16.30 newtons. So we know that the force of the lift, sine 20, plus the tension, cosine 20, equals 16.30 newtons. But now we still have force and tension. So what I did was I just did the quick substitution. So force, so I just isolated force on both sides because we don't, in the question, it doesn't ask for the force of the lift, it just asks for tension. So if you isolate force, you can equal these two equal to each other from your y and your x equations, and then you can just cancel out force and just have the remaining variable be tension. So the force of the lift equals T sine 20. This is from the first equation. So the force of the lift cosine 20, which is here, equals T sine 20 plus 7.35 newtons. So you're just moving this T sine 20 to the other side. And then in order to isolate it, you just divide this whole equation, this new equation, by cosine of 20. So you just take this and you move it over. So you just divide T sine 20 over cosine 20 plus 7.35 newtons over cosine 20. And sine over cosine is tangent. So you get the force of the lift is tension times tangent 20 degrees plus 7.35 newtons over cosine 20. So then that's in the y direction, so I'm also going to do it in the x direction. So force of the lift sine 20 equals, if you go back to this equation, I'm just moving this tension to the other side, so it's negative tension cosine 20 plus 16.30 newtons. And you just divide the tension, then you're going to get the sine of 20. You're just going to get negative t cosine 20 over sine 20 plus 16.30 newtons over sine 20, which means that the force of the lift, because cosine over sine is cotangent, which is just 1 over tangent, it's negative tangent cotangent 20 plus 16.30 newtons over sine 20. So now we have our our lift and our lift, and do two different equations for lift, so we can equal them to each other and solve for t. So first we have it from the first equation, t tan 20 plus 7.35 newtons over cosine 20 equals our second equation, which is negative t cosine 20, cotangent 20 plus 16.3 newtons over sine 20. So what I did was I moved this over to this side. I moved this over to this side, and because it's tension times tan 20 and then tension times cosine 20, what you can do is you can take out tension. It's like the reverse distributive effect or something, and then it's just tension times tan 20 plus cosine 20, which if you just plug it into your calculator is 3.11, and then this monstrosity minus this monstrosity, and if you just plug it into your calculator, you get 39.84 newtons, and you just divide by 3.11, which means that the tension is 12.81 newtons.